We're going to look at quadratic systems, systems involving quadratic equations. You may have a linear quadratic system where you have a straight line and a parabola. The solution to that system would be where that straight line hits that parabola. Or you may have a quadratic system where you have two parabolas. The solution to that system would be where those two parabolas meet. You can solve systems involving quadratic equations using methods similar to those used to solve systems of linear equations. The points where the graphs of the equations intersect represent the solutions of that system. If you have a linear quadratic system where you have a straight line and a parabola, one situation is where you would have just one solution, where that straight line hits the parabola in just one point. Or you may have two solutions, where the straight line and the parabola intersect in 2 points. Or finally, you may have no solution where the straight line does not hit the parabola. So if you have a linear quadratic system, a solution is where the straight line hits the parabola. The straight line may hit the parabola in 1 point, one solution, may hit the parabola in 2 points, two solutions, or they may not intersect at all, and that would be a case where there is no solution. We're going to solve this linear quadratic system. That first equation is a quadratic equation because the highest exponent is 2. The graph of that equation would be a parabola, a U-shaped graph. Second equation is called a linear equation. The graph of that is a straight line. The highest exponent is 1 on that equation. So we're going to find out where that parabola and that straight line intersect. We're going to find the solutions to that system, if they do intersect. Notice they're both equal to y, so y equals negative x squared minus x plus 6, and y also equals x plus 3. Well, if those are both equal to y, that means you can set them equal to each other. So you can set x plus 3 equal to this negative x squared minus x plus 6. Now you have a quadratic equation that you can solve for x. You can get everything to one side equal to 0. It's a good idea to keep the x squared positive for factoring reasons. So we're going to add x squared, add x, and also subtract 6 from each side. When you do that, you get x squared plus 2x minus 3 is equal to 0. So we have everything to one side equal to 0. The x squared is positive. We can now factor that into two binomials. The first terms of the two binomials multiply to make x squared, so the first terms of the two binomials would be x and x. The second terms of the two binomials multiply to make negative 3 and add to make 2. So two numbers that multiply to make negative 3 and add to make 2 would be 3 and negative 1. So x plus 3 times x minus 1, those are the two binomials that factors into. Now those two multiply together to equal 0. So if they both multiply together to equal 0, that means you could set each one equal to 0 because either one could be equal to 0. So x plus 3 could be 0 or x minus 1 could be 0. Now you have two simple equations that you can solve for x, and that first one subtract 3 from each side to get x equals negative 3, and the second one add 1 to both sides to get x equals 1. So we have two values for x. That means we'll have two solutions, 2 points of intersection of this parabola and the straight line. So this straight line goes directly through this parabola, hitting in two places. But we need to find the y values. So to find the y values, look back up here to these two equations. Pick the one that's the easiest to work with. Y equals x plus 3 would be easier than y equals negative x squared minus x plus 6. So we're going to use that equation, y equals x plus 3. We know that x equals negative 3. So to find the value of y when x is negative 3, substitute that in. Also to find the value of y when x is 1, substitute that in. So we're going to have two different y values here for these two different x values. So if you substitute negative 3 in for x, you would have negative 3 plus 3. That's what y equals. And if you substitute 1 in for x, you'd have y equals 1 plus 3. So if y equals negative 3 plus 3, then y equals 0. Just add negative 3 and 3. And if y equals 1 plus 3, then y equals 4. So when x is negative 3, the value of y is 0. That's 1 point of intersection. Negative 3 is 0. And if x is 1, y is 4. That's another point of intersection, 1, 4. So this system has two solutions, 2 points of intersection. They are negative 3, 0, and 1, 4. When I graph this system, when I graph the quadratic equation and the straight line, you're going to see the straight line and the parabola hit in two places. These 2 points, negative 3, 0, and 1, 4. So you can see the points of intersection are negative 3, 0, and 1, 4. So what is the solution to that system? Y equals negative x squared minus 3x plus 10, and y equals x plus 5. So again, we have a linear quadratic system. You have a straight line, y equals x plus 5, and you have a parabola, y equals negative x squared minus 3x plus 10. we're going to find out where the straight line and the parabola meet, if they do meet at all. Notice they're both equal to y, so negative x squared minus 3x plus 10, that's equal to y, and x plus 5, that's equal to y. Well, if they're both equal to y, that means they're equal to each other. So you can set x plus 5 equal to that negative x squared minus 3x plus 10. Now this is a quadratic equation that you can solve for x. You can get everything to one side equal to 0. Try to keep the x squared positive. It's easier to factor that way. So we're going to add x squared, add 3x, and also subtract 10 from each side. When you do that, get x squared plus 4x minus 5 is equal to 0. Now this will factor into two binomials. The first terms of the two binomials make x squared, so it'd be x and x. The second terms of the two binomials multiply to make this last term, so they multiply to make negative 5, and they add to make this middle coefficient, this coefficient of x, they add to make 4. So two numbers that multiply to make negative 5 and add to make 4. They would be 5 and negative 1. So the two binomials that factors into are x plus 5 and x minus 1. Now these two multiply together equals 0. That means either one of those could be equal to 0. Because if you have two or more things multiplied together equaling 0, any of those could be 0. So x plus 5 could be equal to 0, or x minus 1 could be equal to 0. Now you have two simple equations that you can solve for x. In that first one, subtract 5 from each side, get x equals negative 5. In the second one, add 1 to both sides, get x equals 1. So we have two solutions, two values of x. That means we'll have two values of y, two corresponding values of y. If x equals negative 5, we're going to substitute that back in. And you want to pick the equation that looks the easiest to work with. I'd avoid the quadratic equation because of the squared term and the three terms in general. I'd go with the y equals x plus 5. That looks pretty easy to substitute into. Substitute negative 5 in for x. When you do that, get y equals negative 5 plus 5. But also substitute 1 in for x and get y equals 1 plus 5. So when x is negative 5, y is going to be 0. And when x is 1, y is going to be 6. So we have two solutions, 2 points of intersection. They're negative 5, 0, and also 1, 6. So 2 points of intersection when I graph these two equations. When I graph the parabola and when I graph the straight line, they're going to meet at the points negative 5, 0, and 1, 6. And you can see that points of intersection are negative 5, 0, and 1, 6. We're going to solve this system, y equals negative x squared minus 3x plus 2, and y equals x plus 6. Notice, negative x squared minus 3x plus 2 is equal to y, and x plus 6 is equal to y. So if they're both equal to y, then you can set them equal to each other. Set x plus 6 equal to negative x squared minus 3x plus 2. That is a quadratic equation. You can solve that for x by getting everything to one side equal to 0. And try to keep the x squared positive. So we're going to add x squared, add 3x, and subtract 2 from each side. When you do that, get x squared plus 4x plus 4 is equal to 0. Now that is actually a perfect square trinomial. It's in the form of a squared plus 2ab plus b squared that factors into a plus b squared. So if you recognize that's a perfect square trinomial, just take the square root of the first term, square root of x squared, that's x, and the square root of the last term, the square root of 4, is 2. If you don't know anything about perfect square trinomials or don't recognize that, you could still factor it the old way. First terms would be x of the two binomials. The second terms would multiply to make 4 and add to make 4. That'd be 2 and 2. So no matter how you factor it, you'll still end up in the same place. X plus 2 times x plus 2 is equal to 0. Now these two multiply together to equal 0, but they are the same thing. So there's no sense setting each one equal to 0. Just set x plus 2 equal to 0. So if x plus 2 equals 0, subtract 2 from each side, get x equals negative 2. That is the x-coordinate of the point of intersection. Notice, there's just one x-coordinate this time. That means there'll just be one point of intersection of this straight line and parabola. So the straight line and parabola are only going to meet in one point. So if x equals negative 2, we want to substitute that back into one of these two equations to solve for y. You want to pick the equation that looks the safest, easiest to work with. So go with the equation y equals x plus 6. If you want to live life on the edge, go with the equation y equals negative x squared minus 3x plus 2. We're going to substitute negative 2 in for x. So it'll be y equals negative 2 plus 6, and that is y equals 4. So when x is negative 2, y is 4. That is the point of intersection of that parabola with that straight line. They meet, as you can see behind me, well, you can't see until I move, they meet at the point negative 2, 4. X is negative 2, y is 4. That is the point of intersection of that straight line and parabola. You can solve a quadratic system. That is a system of equations involving two parabolas, using the same method you use to solve linear quadratic systems. So we're going to solve this system of equations. Y equals negative x squared minus x plus 12, and y equals x squared plus 7x plus 12. So there you have two parabolas. We're going to find out where those two parabolas meet, if they do. Notice they're both equal to y, so set them equal to each other. What I mean by that is set this negative x squared minus x plus 12 equal to this x squared plus 7x plus 12. So there you have a quadratic equation that you can solve for x. Get everything to one side equal to 0, but try to keep the x squared positive. So we're going to add x squared, add x, and also subtract 12 from each side. In other words, we're moving everything from the left side over to the right. When you take x squared plus x squared, that is 2x squared. 7x and x is 8x. And then 12 and negative 12, that makes 0. So 2x squared plus 8x is equal to 0. Always look for a common factor that you can factor out. 2x squared and 8x, the common factor there is 2x. If you factor 2x out, divide each term by 2x. So divide 2x squared by 2x, that is x. And divide 8x by 2x, that is 4. Now those two multiply together to equal 0. 2x times x plus 4 is equal to 0. That means either one of those could be 0. So 2x could be equal to 0, or x plus 4 could be equal to 0. If 2x equals 0, divide each side by 2, get x equals 0. And if x plus 4 equals 0, subtract 4 from each side, we get x equals negative 4. So we have two values for x. That means we'll have two solutions, or 2 points of intersection. But we still need to find the y values. So we have to substitute these values for x back into one of these two equations. So you have to pick one of those two equations to work with. I'd stay away from the one that has a negative x squared. More chance of making a mistake with that. So I'm going to substitute into y equals x squared plus 7x plus 12. Substitute 0 in for x. Wherever there's an x, replace it with 0. And also we're going to substitute negative 4 in for x. Same thing, wherever there's an x, replace it with negative 4. So you have y equals 0 squared plus 7 times 0 plus 12. That would be y equals 12. And over here, y equals negative 4 squared plus 7 times negative 4 plus 12. Well, that'd be 16 minus 28 plus 12. And that turns out to be 0. So when x is 0, y is 12. And when x is negative 4, y is 0. Those are the 2 points of intersection of those two parabolas. They meet at the points 0, 12, and negative 4, 0. And you can see that on the graph. The point 0, 12, the two parabolas are meeting. And the point negative 4, 0, the two parabolas are meeting there as well. With those two parabolas, one opens upward, one opens downward. The parabola that opens upward is the one with the coefficient of x squared being positive. So that blue parabola is this second equation, and the parabola that opens downward is where the coefficient of x squared is negative. So that red parabola, that is this first equation. So again, 2 points of intersection, those two parabolas meet at the points 0, 12, and negative 4, 0. We're going to find the solution to this system, y equals x squared minus 4x plus 5, and y equals negative x squared minus 5. Notice they're both equal to y, so set them equal to each other. In other words, set x squared minus 4x plus 5 equal to that negative x squared minus 5. There you have a quadratic equation that you can solve for x. Get everything to one side equal to 0. So add x squared and add 5 to both sides. That keeps the x squared positive. When you do that, you get 2x squared minus 4x plus 10 is equal to 0. Always look for a common factor that you can factor out. 2 is a common factor to those three terms. So if you factor 2 out, divide each term by 2, and that's what goes in the parentheses, x squared minus 2x plus 5. Now you can get rid of that 2 by dividing each side by 2, because 0 divided by 2 on the right will still be 0. So if you divide each side by 2, get x squared minus 2x plus 5 is equal to 0. Now you might try factoring that into two binomials. The first terms of the two binomials would be x. The second terms would multiply to make 5 and add to make negative 2. But that's a problem, because there are no two numbers that multiply to make 5 and add to make negative 2. So it does not factor. If it does not factor, you'd have to jump to the quadratic formula. But it may not even have real solutions. So what you want to look into is the discriminant, the part under the square root sign of the quadratic formula. The discriminant, the b squared minus 4ac, if that's positive, you would have two real solutions. If it's 0, you'd have one real solution. But if it's negative, you will have no real solution, meaning these two parabolas would not meet. So we're going to take that, x squared minus 2x plus 5, pick out a, b, and c. A is 1, b is negative 2, c is 5, and substitute those into the discriminant. So taking b squared, that is negative 2 squared, minus 4ac, it'd be minus 4 times 1 times 5. Now again, if this is negative, that means there are no real solutions. Square negative 2, that is 4. Take negative 4 times 1 times 5, that is negative 20. And look there, 4 minus 20, that is negative 16. So the discriminant, the part under the square root sign of the quadratic formula, the discriminant is negative. If the discriminant is negative, you will have no real solutions. So there are no real solutions to that equation. That means these two parabolas do not meet. And you can see that when I graph that these two parabolas do not meet. There were no solutions. You were not able to solve for x with no real solutions, not able to solve for x. And therefore, you can see from the graphs, there is no point of intersection, no solution.